Yes, friends, we are meeting again in tutorial 18 and in distance series tutorial 6. We are talking about problems in distance measurement. First problem was direction. If direction means the relay has to see in forward direction. If relay sees the fault behind it, then it will create hazard. Second problem was fault resistance, because of which the distance relay underreaches. Underreach of more relay is less than impedance relay. Underreach of reactance relay is nil. It is immune to fault resistance. But more relay can incorporate some fault resistance. But the best relay is the, quadrilateral relay about which we were talking. So these two problems we talked, and now we enter into the third problem, that is close-in fault. So what is close-in fault? Close-in fault is the fault. After all, how does the relay measure impedance? It creates the torque. Torque is proportional to VI cos phi. Rightly speaking, torque is proportional to VI cos phi minus theta, where theta is the angle at which the fault occurs. If the, theta is, phi, theta is the rather design, not the angle at which fault occurs. Theta is the design angle. But phi is not our control. Phi is due because of the location of the fault. If phi is far, then R is there, and therefore theta, the phi is less. If relay is nearer to generator, phi is practically 90 degree, right? Theta is the characteristic angle that is decided by relay manufacturer. Now torque is proportional to VI cos phi. If you say that I'm talking about a fault at a particular location, so phi is constant. Phi is constant. So if theta equal to 0, right, then torque is maximum. That is known as maximum torque line. But if the fault occurs very near to the relaying point or just after relaying point, then then voltage equal to 0. There is no problem of I. I is 10 times the rated current. But phi is also there. But voltage is not there, so relay will fail to operate. The remedies are ultra sensitivity. With the advent of static relays, if the voltage is less, it could not operate the relay. Then you increase the, you amplify the voltage twice, thrice, and make the relay to operate. So what is the meaning of voltage? Voltage is IZ, and Z means the line length. Z is proportional to line length. So the close-in fault has something to do with line length. In electromagnetic relays, what was there? That there was a cup which was moving over a bearing. Bearing has some friction. So you have to, one has to pass over that bearing torque. One has to cross over that bearing torque. One has to take care of that bearing torque. Second thing, you cannot keep the voltage, the fixed and moving contact like that only. Moving contact has to be literally stretched by a very tiny spiral spring, because otherwise it will operate by vibration. That is wrong. So that you have to take care of that. You have to restraining torque, the operating torque has to overcome that bias of the spring also. So in electromagnetic relay, the dead zone means the non-operation of the relay in right direction was more, say some 5 kilometers, say for example, for the sake of example, out of 100-kilometer line, 5 kilometers is not seen. That is wrong. But if static relay is there, voltage can be improved by ultra sensitivity. 5 kilometer can be brought to 1 kilometer, right? So that is one remedy. Another remedy is memory action. You memorize the relay. You memorize the uh, voltage before the fault. It was full voltage. So full voltage upon the current. So no doubt, impedance is wrong, but relay was otherwise not operating. Now it will operate. So you memorize by some action, usually by charging the capacitor. Or otherwise you polarize the relay with unfaulted phase. RY fault has occurred, so VRY is 0. Don't feed VRY, feed VBR or V by B. Feed some another voltage. But my friends, if RYB fault occurs, then none of the remedy is useful because all voltages are 0. Memory action cannot be done because capacitor will be shorted and it will be 0. Other voltages also are 0, right? You cannot amplify. How can you amplify 0? Even if there is static relay, 0 cannot be amplified. 0 is amplified 100 times. It is yet 0. So then distance relay really fails. Triple line to ground fault immediately after relaying point, and that is the only possibility that earthing switch is on and circuit breaker is inadvertently made on. That is the problem. Then the relay will fail to operate. And then you have to forget the distance relay. Numerical relay people, what do they do? They measure the voltage when the fault occurs. If the voltage is less than 15% of the rated voltage, usually 110 volt rated voltage. If it is less than 15% of 110, then it will block the distance protection and it will hand over the uh, relay, hand over the protection arrangement to backup overcurrent protection. So that overcurrent is already there, so relay will operate. That philosophy of switch on to fault is similar to this figure, which we in earlier days people were using in electromagnetic and static relays. This figure has nothing to do with distance relay. This is purely instantaneous overcurrent relay. 50R, 50Y and 50B will operate. They are set for fault immediately after relay. So when they operate, 2 by 50x timer is there. 86 will be energized and breaker will trip. But the timer 52/1 is energizing the timer also. That timer is a 4-cycle timer. So earthing switch is on and breaker is on. That means fault is already there and then breaker is made on. That cannot happen after 4 cycles. You see, that is not possible. So after 4 cycles, that is not the case. Then distance relay will take over. Distance protection scheme will take over. Otherwise, this scheme will operate for triple line to ground fault immediately after relaying point. So the problem of closing fault is solved like this. The next problem is overload. Overload is what? That the line is overloaded. As I was telling to you other day, line can be overloaded to 200%. Why 200%? Because in transformer there is insulation, motor, generator. But in transmission line, insulation is air and the porcelain. Air, because of overload, will become hot. hot air will go up because of less density. New, fresh, cold air will come which has full dielectric strength. So it never fails. Porcelain has got very high temperature resistance. It is highly temperature resistant. So overload is not a big problem to transmission line. But then I don't mean that we allow that overload. The person who is shooting at receiving end will see that line is being overloaded. He will take actions to shed the load, but that shedding will take some 4-5 minutes. Within that time, the relay should not operate. Now, what happens is this, that this is my normal load region. My normal load point is P at angle about 30 to 36 degree, as I was telling to you, because normal power factor is 0.86. So between V and I, the current is 36 degree. Overload means voltage is constant, power factor is also constant, but current increases, therefore that point comes towards the characteristic. And by chance, if the point enters into third zone, then in third zone time, the relay will mal-operate. I am telling mal-operate because overload is not fault and relay should not operate. I don't mean that overload is not a problem. That has to be looked after by some another thing, but not by the distance relay. So this problem, how this problem is solved? This problem is once again solved by the, so to say, the quadrilateral relay. How is it solved? See, this compares all other characteristics also. Point P is there. It enters reactance relay first. So reactance which is best for fault resistance is worst for overload. Then the point will enter impedance. So impedance is little better than reactance, but more is better. But quadrilateral with this notch is best. Is best, right? Therefore, the quadrilateral relay nowadays in all EHV transmission line people prefer quadrilateral relay. Reliant version relay REL 650 of ABB gives such a characteristic, and therefore you see line will be line can be loaded to large extent, loadability will increase, and if loadability increases, line trippings are less, and if line trippings are less, then availability of the line is more, and if availability of line is more, then the if the availability of the line is more, then more money will be received by the electricity company, right? So that is the advantage of this overload. So this is the problem of overload. At the end, I always tell one sentence told by Swami Chinmayanji. Remember, even this will pass away. I'm reminded of a story told by Osho Rajneesh, that there was one king. He was attacked by his enemy king, and his Sainiks, his army went away. They were frightened. The other army was big. Then this king also had to rush. He went on his horse and he tried to save him. His friend, his very fast friend was with him. Both hid somewhere. But the horses of the enemy king were coming. They were very frightened. Friend told that if they catch us, that fellow will kill us. But what happened? What had happened that before about 10 years, this king had met one saint, one fakir. He told that if I have to, I'm a king, I may have to come into a very worse situation. If I come into a very worse situation, what should I do? You please advise me. That saint gave him a chit, folded. Don't open it. He also told that don't open it. And he put it in his locket, which he wears in the neck. That king at that time opened that chit, which was given that when now I am going to die. In the chit, this was written. Remember, even this will pass away. So king was very calm. This will pass away. Don't worry. This will pass away. The horses, the noise of the horses were going away. People, the uh, enemy horses went away. Then this king slowly came out. He collected other friends and then he once again attacked that king and he killed him. He became, once again, he got back his throne. He got back his state. He came on elephant. People were praising him. That friend was yet on elephant with him because he was a very fast friend. But this fellow was yet calm. He was not very happy. Oh, this is very good. Not like that. That friend asked that on that day, on today, you should be very happy. You kill that king and you got your back, you got the state back. You should be very happy. But then this fellow told that no, remember, even this will pass away. Nothing is permanent. Anicca, anicca, anicca. Bhagwan Buddha used to tell. Anicca means anitya. कुछ भी चीज नित्य नहीं है, नित्य एक ही चीज है जो भगवान बुद्ध ने सिखाई. खैर, I am not here to talk about Bhagwan Buddha's teaching. So I leave this slide, but I tell you that don't forget adapt me, right? This videos, free videos of adapt me should reach to each and every electrical engineer of the world. All engineers of the world should hear these videos. I don't want to say that I'm the best man in the world in protection. 100 times better persons than me are there in the world. 10 times better persons are there in the world. But they are not preparing videos. I am preparing videos. And I am giving you something. And when you are getting a good education from a protection expert, you should thank that protection expert. Rather than thanking protection expert, you should thank the organization who has given that protection expert also a platform. So I thank Adapt.me. You also thank Adapt.me. And I thank you too. Good night.